Hi everyone. I hope you guys are all doing well, getting ready for the exams, and you're finding these videos very helpful. In this video, I'm going to help you solve strategic games and how to determine a Nash equilibrium to help you solve some of the problems in chapter 10 and 11. And to do so, I use a set of slides that basically discusses all the key basics and setups. And I hope that if you pay close attention to this, it will all make perfect sense. So basically, to solve the strategics game, we use the general idea of game theory, which is a tool for studying the strategic behavior, right? And there are four key things to understand that basically set up the strategic game. There's rules, there's strategies, there's payoffs, and basically the outcome, which is what will each person do. So we'll walk through an example of a prisoner dilemma, which basically shows how two people will react and make strategic decisions given what each of the other players do. So the rules of most strategic games are that each player has certain actions to take and they each have certain consequences. So for example, in this prisoner dilemma, which is the famous setup for these games that's usually taught, there's two prisoners each held in a separate cell and they can't communicate with one another. So basically there's two strategies that they each have. The game can have a lot more strategies, but in the simplest form, in the form that is used to solve some of the problems in chapter 10 and 11, there's basically two different actions that they each can take. Either confess to a crime or deny. And given their choice, and depending on what the other person's choice, there's a different outcome for them. So without further ado, let's basically look at how we set up this game in order to solve it. So basically we see two people here. So we have person A up here, and their choices are to either confess or to deny. And their payoffs are shown with the pink background. And then we're going to go step by step to show you exactly how to solve them. So those are the payoffs for person A. And then over here, we have person B. And they also have the choice to confess or deny. And these are their four payoffs, depending on each of the four cases, which is basically 2 times 2 is 4, right? So depending on what each player does, there's a different payoff. So in order to solve these games, we got to think about how each person makes their decision given a decision of the other person. So for example, that's basically how we get to find the Nash equilibrium, is by each player making a rational decision given each of the decisions of the other players, and then we see if there is one outcome or several outcomes that could occur. Each of those outcomes is called the Nash equilibrium, after John Nash, the brilliant mathematician who basically developed this theory. So here we think about person's B decision. So person's B decision thinks and says, okay, what if person A confesses? Then my two payoffs are either 3 years if I also confess, or 10 years if I deny. So because this is a payoff in which it hurts, right? It's 3 years of prison or 10 years of prison, a lower number is the better choice. So in that case, the choice is to confess. So conditional on person A confessing, person B will confess. So we look at these two columns and we compare the two payoffs. We look at this one column and we compare the two different payoffs for person B. Then we look at person B's decision on what happens if the other person denies. And if the other person denies, we look and we compare now the payoffs if I also deny or if I confess. And it looks like in this case, again, 1 is less than 2. So once again, the best choice is to confess. So overall, we see that B confesses no matter what the other person does. So let's see what happens with person A. So now basically we look and see person's A decision, what happens conditional on person B confessing. So at this point, these are not relevant. When we look at person A, we don't care about the other person's payoffs. We really compare just his payoffs. So in this case, there's a payoff of 10 years if he denies, or just going to prison for 3 years if confess. So confess is the option. So he's going to confess given that person B confesses. And then if person B was to deny, again, we don't care at all about these. So we just compare this with this. And once again, it looks like confessing 1 year is better than 2 years in prison. So once again, it's going to confess. So all in all, A confesses independent of what B does. Okay, so basically then when we look at it all together, we see that there's a Nash equilibrium where they both confess. And the Nash equilibrium is the upper left quadrant. So the problem when you split it up accordingly and you take it step by step is pretty straightforward. The trick is that when you look at it all together, if you don't know exactly which part to look at first and how to look at one column and then the other column, and when you look at one column, so let's say I'm looking at this column, right? When I'm looking at a column and I'm choosing in between these, I got to make sure that those are what I'm choosing in between when I'm picking the first column. I'm not picking between the pink, right? Because this is person B's decision given A's option. So when we choose the first column, person A has made the option to confess, and we look at person's B choice to either confess or deny. And then when we look at the second column, it's the same thing. And when we look at the rows, I think if you watch maybe through the video one more time and maybe take a close look at the slides and work through them, the key here is to understand how to take it bit by bit, look at the correct information, and then it's just comparing two numbers, which one's higher if the payoff is positive or which one's lower if the payoff is negative. Thank you so much for taking the time to watch this video. I hope it's really helped, and I hope you guys all do great on your exams. All the best.